Okay, today in class we went over Investigation 3, continuing our conversation on the seasons. Gave out some vocab words in class. Some of the vocab words: revolve, the movement of one object around another, as we're looking at the Earth and the Sun, and how the Earth revolves around the Sun. The next word: axis, the imaginary line on which the Earth rotates. So the Earth is going to rotate on a axis at a tilt of 23.5 degrees. The Earth is also going to have some rotation, how it spins like a top while it is turned on its side, and that's going to give us the difference between day and night. We're also going to talk about how the North Star plays a role. We're going to have the North Pole always pointed towards the North Star as the Earth revolves around the Sun at every position along that revolution. The North Pole and the North Star are going to be lined up. We have our equinoxes. These would be our spring and our fall. That's where we're going to have essentially 12 hours of daylight and 12 hours of darkness on these 2 days during the year. And then we have our solstices. With the solstice, we have our summer solstice in the northern hemisphere, that's June 21st, and our winter solstice in the northern hemisphere, that's going to be December 21st, and that's our shortest day of the year in terms of light. We look at some other terms here. Beam spreading. As a vocab word, we're going to talk about how the angle of sunlight is going to be spread out across the surface of the Earth. In the summer, that beam spreading is going to be very, very small, and the solar energy is going to be very concentrated, and it's going to help warm up the Earth more. And in the winter, that beam of light is going to be very, very spread out because the Earth is round, and the Earth is going to be, or the northern hemisphere, tipped away from the Sun, so the light's spread out more over the surface, not as concentrated, and weaker. Same thing with the solar angle, goes hand in hand with beam spreading. In the summertime, the solar angle is going to be much more overhead, or closer to 90 degrees. In the winter, that solar angle is going to be a little bit sharper, or more indirect, and it's going to cause a solar angle with beam spreading, giving us very, very weak solar energy. So those are some of the vocab words that we have for this section on the seasons. Some of the different diagrams that we looked at today in class. We looked at how the Earth and Sun are kind of oriented in outer space. So looking down, if we were able to get out of our solar system and look at the Sun and the Earth, obviously, like it says here, not drawn to scale, but we can see the Sun in the center in a nearly perfectly circular orbit. The Earth's orbit is not perfectly circular, but it is very, very close. We are a little bit closer to the Sun in the winter than we are in the summer. So as we move into this, we can kind of see this is the perspective that we're going to be using as we look at the seasons. So we start off here, January 21st, and we can see that the North Pole is tipped away. This is a winter month. From this angle, it's very, very tough to see exactly how little light we are getting, but if I switch to the top view, we can kind of see half of the Earth in daytime and half of the Earth in nighttime. Very, very easy. As we change through the months, okay, we go into February and then into March. With March, remember that we don't have entire darkness. Just from our perspective here, we are looking at the nighttime side of the Earth with the sun shining light on the opposite side. So again, still half of the Earth in daytime and darkness. Okay, if we switch to that side view, okay, it's not all in darkness. We're just looking at the nighttime side. Switching back, actually changing months. So we go to April, okay, and then to May. Again, we can start to see that the northern hemisphere is going to be getting some more light. You can see that the North Pole is now in the daytime side. Let me switch back to this side view. June 21st, this is our summer solstice. This is the day which the northern hemisphere gets the longest hours of sunlight, and we could see that the North Pole is tipped the most in towards the sun. At this point, if we go down to the top view here, we can see that most of the northern hemisphere is in the daytime side. In fact, the North Pole and areas around Alaska will receive nearly 24 hours of daylight on June 21st. As we change through the next couple months and we start working our way to our fall equinox, we can see we again have half the Earth in daylight and darkness. From the side view, it does look like we see only sunshine, but that's only because of our perspective where we see only the daytime side of the Earth. The sun can only shine on half of the Earth at one time because it is round. So none of the light will make it to that nighttime side. As we continue moving, we're going to see more of the northern hemisphere into darkness until we get to December 21st, our winter solstice, where we see some areas of northern Alaska would not even get any light at all on these days. The sun doesn't even light up. If we change to the side view, you can see that the North Pole is pointing away from the sun, okay, as it's tipped away, and then we have our southern hemisphere in total light. So we looked at before our North Pole getting very little light, and on the contrary, our South Pole, Antarctica, is getting a nearly 24 hours of light, where they are in their summertime right there. So from that side view, we could see there. If I change this to the top view, you can kind of see how if we pick some place close to Pennsylvania, Virginia in this case, we could see how the hours of daylight change as we go through. We see very little of the path there in the daytime as we change through the different months. Okay, when we get to March, we see half of the circle in daylight, half of the circle in darkness, and that will start to increase as we get to June 21st, where we see more of the circle in the daytime side, less of the circle on the nighttime side. And again, that will change back as we get to fall. Okay, exactly half the circle in daylight, half the circle in darkness. And we go back to winter, where we see most of the circle in darkness, very little of the circle in daytime. When we start to look at a graphic of this, I'm going to had everybody draw a picture of this in class, where we see the Earth, okay, going around counterclockwise around the sun. With this, we put some labels on there. Okay, again, the biggest thing looking at the different seasons is the tilt of the North Pole. When we have the North Pole tilted towards the sun, that would be summer. When we have the North Pole tilted away from the sun, that's winter. We notice at each season we see that the North Pole is pointing towards our North Star, or in this case for the diagram we have that pointing to our upper left corner of the paper. And we see again at every season. With fall and spring, we see that the North Pole is not pointed towards or away from the sun. It's kind of in the middle, so that way we kind of see a mirror image, if you will, of the Earth in spring and fall. Again, looking at just the daytime side in the fall, with the sun shining on that side, and with the sun's light shining on the opposite side of the Earth, we see just the nighttime side here in the spring from this perspective. If you have any questions about the seasons and how the Earth orbits the sun, please stop by and ask in class.